If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Let's try this. Hello, my name is James. Welcome to an AddOhms live stream, or Bald Engineer live stream, or live stream hosted by the Bald Engineer. Anyway, Happy New Year. It's 2020, which is crazy to think about just in terms of like time and year, but Happy New Year to everybody. Happy New Year to everybody in the chat. Hope you guys like the trivia. I've been putting that together over the last couple of, I guess, months now. There's like 37 questions at the moment, and I try to keep adding some more. In this live stream, there's a couple of things I want to get done. So the first thing we're going to start with is actually a KiCad project that I was streaming about just about a year ago. It's recreating the schematic for an Apple II GS. So I've got let's see which side it's on. So I've got this PDF schematic that we're turning into a KiCad schematic. In fact, we've actually done quite a bit already. And so what I want to work on today is the bypass capacitor page, which is a whole bunch of caps that I'm hoping we can just write a Python script to basically get the parts created, and then we'll go from there. All right, let me just catch up with chat real quick. Happy New Year, everybody. Happy 2020. You know, I've actually got a number of things planned for throughout the year. In a couple of months, I'm moving, which is, I'm pretty excited, primarily because in terms of video, I'm going to have a much larger studio/lab space. The biggest thing I'm excited about there is having more than one workbench so that I'm able to work on multiple projects at a time. And then right around then, I'm actually planning to hire an editor because with the number of video projects that I'm doing at the moment, I just don't have time to do my own editing, which will hopefully allow me to get back to making AddOhms videos because I've actually got one complete script done, and then I've got an outline for another and like 5 or 6 ideas I want to work on. I just don't have time to shoot it. So anyway, I've got a lot of plans for 2020. I hope you guys have plans for 2020. A question I asked in the AddOhms Discord yesterday related to the fact that, okay, we're into a new decade. And yeah, I know 2021 is actually the new decade, but whatever. 2020, it's a new decade. what is something that you learned in the last 10 years that you wouldn't have thought 10 years ago or 15 years ago you would have actually learned how to do? For example, 10 years ago, I was happy using Eagle. And about 5 or 6 years ago, I switched to KiCad and I never went back. So, just as an example of something that I learned how to do in the last 10 years that I would have never even thought about. So what about you? What's something that you learned how to do in the last decade that you probably wouldn't have expected to learn? And it doesn't even have to be electronics related, but let me know in the chat. All right, so let me just do a quick, so what I said we're going to do is we're going to work on this Apple IIgs schematic. Just as a reminder, I have a project called Bit Preserve on GitHub. In fact, let me show you that. Come over here, make this bigger. And so Bit Preserve has a bunch of schematics for a number of computers that multiple people have contributed to the repository. The idea is we want to recreate vintage electronics, and right now I'm focused on computer schematics that are only available in the scanned PDF formats, which are not all that usable and sometimes unreadable, and sometimes they have mistakes. And so the project that I'm working on is the Apple IIgs. Okay, and the reason I'm doing that is because I have a plan for a portable Apple IIgs based on, let me make this bigger for you, based on this chip here, which is the Mega 2 chip. I just realized you guys don't see, the thing is, oh man, it's not in here. Let's see if I can add this real quick. Nope. Shoot. That was not the button I meant to press. Okay. I was trying to get the chat to come up on screen. Oh, I know what I could do. No, because I already can't see. A lot of you are on YouTube, but there's a handful of you on Twitch and 1 or 2 on Facebook. I'm seeing all the chat messages from all the places, but you guys just don't get to see each other. So, okay. Ruda, appreciate your enthusiasm, but we do not need to create a WhatsApp group. And, let's just stick on topic, or, bad things can happen. Okay, let's get back to my schematic. So what I was saying is I'm creating a portable Apple II, and the idea is there is a mega chip inside of the Apple IIgs, which combines all of the logic from the original Apple II into a single ASIC. And then all you need to do is add a processor and some RAM, and then you've got an Apple II. So in order to create the PCB, I had to create the schematic of the Apple II Mega, and so then I just decided to do the entire IIgs. Today's task is I want to recreate the bypass capacitor page, which is just a bunch of capacitors. Now, one approach could be, we could come in here and just add and copy paste, but I wanted to try and see if we couldn't do like a Python script to go through each of these. So let me make one change, because I don't actually want that in there. And then I'm not going to worry about those. Let's actually get these out here, and you'll see why I want to do this in just a second. All right, so let's go ahead and do 0.1 UF, and it looks like BC01. Now what I want to do is copy and copy, and then copy and copy. Okay. So now we'll go ahead. What I want to do is, okay, so here's my plan. I'm going to put these 5 capacitors into the schematic, then I'm going to save it, and then we're going to look at the text file and see if we can figure out if we can figure out how, I just realized these are not labeled correctly. It should be BC02. All right. All right. Okay. Wow, we only got a few minutes in and I already have to, wow, all right. I gotta do one quick thing over here. So let's just do a quick timeout on this person. And what's going on? Come on, guys. All right. Let's now come back to desktop. All right. And the other thing I'm going to do is yeah, Ruda, I timed you out. I've already asked you once. We're not creating a WhatsApp group. Do not share a phone number for a WhatsApp group. If you're not here to talk about electronics, AddOhms, or schematics, or anything that's on topic, then I will ask you to leave. Now that we've got that over with, let me turn on some music because I'm not going to be doing a ton of talking. All right, so let's see. Got a couple of capacitors here. I want to rename this one to BC51. So now I'm trying to get refocused. My plan here is, why did that happen? I want to write a Python script to basically copy and paste these for me. I know we could just copy and paste all of them, but I think it'd be kind of fun to, I think it would be fun to figure out the Python stuff. So let's save this now, and then I gotta go find it. No projects, GitHub, Apple 2, and GS. All right. So come into here, and I'm looking for, it's capacitors-6. That's the backup file. Let's open this up in Sublime. And this is a little more complicated than I thought it was going to be. All right, so comp, incomp, device, C small. I wonder, is this the placement? I'm thinking it is. This must be an ID. That's the labels. Okay, so, this is a lot more complicated than I thought it was going to be. Yeah. Okay. So I didn't think about this. I guess I was hoping it was just going to have like a XY coordinate for the location of the component, but it looks like instead maybe there's like a center point. Oh, never mind. I know what's going on. So this is the location for the text. Okay. All right. Use KiCad library utils from GitHub to make Python scripts. That might be worth looking into. So all we want to do, okay. I'm starting to think maybe it's not even worth doing this in Python. Because this must be an offset. So what is that? 92. And is this one? That's 92, 92. And that's, so that must be XY. That's the Y offset. The X is, this looks like 46, 46, 46. Yeah, I'm realizing this is probably just going to be easier to do it by hand. Bummer. Okay. Well, because, I mean, what we can do is, I could just do this, and then it's already on BC question mark. So we need, of course it doesn't. It goes 8, 9, 10, 11, 12, 13, 39. That's a bummer. All right, so let's do this. Oop. I'm gonna move this back here. And we'll kind of do that. Copy, paste. Copy, paste. So that's 8. 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oop, wrong hotkey. And then this starts 39. So how many is this? 39, 40. See, they're not in order. Yeah, this is, okay, now I'm back to, this is why I want to write a script, because I thought I would just put all the subscripts in series. I gotta think about this now. Hey Kaz, good to see you, man. Happy to hear from you. Saw your message on Discord. Just, I was just checking in since I hadn't heard from you for a while. So here's, okay, I was originally going to try and do this. It didn't save it. Why doesn't, okay. All right, we'll just do it the old-fashioned way. The reason I'm not going to use annotate schematic is because these aren't annotated in the correct order. So 1 through 13 is correct, but then after that, the numbers are all broken up. And I don't think annotate's going to help us any better there. So we'll just do it this way. Was that 12 or 11? Bummer. So what are we making? So we are recreating the schematic for the Apple II GS. The reason I'm doing this schematic is I needed the Mega 2 chip, which is the Apple II in on an ASIC for a project. And that required so much work that I decided to just do the whole schematic. So that's what we're up to. Okay, so 42, 3, 42 and 43. Let's go ahead and just finish these out. Oop. Because next is 50. Oh, come on. 50, 53, 57. They couldn't go in order, could they? Of course not. Of course not. So 50, 53. By the way, if you're not familiar with KiCad, to copy and paste, as I hover over the symbol, I'm just pressing the letter C, which creates a copy, and then I move it over. And then while I'm on the symbol, if I hit the E key, it brings up the symbol properties. But as a shortcut, I'm hovering over the label and hitting E on that, And so it's allowing me to edit the reference. Reference is the word I was looking for, which the only reason I want that one is because of the way that the enter key is mapped on the symbol dialog, but that's a detail. But anyway, I just wanted to make sure. So E60, enter, and then we're getting there. All right, so 61, so we got 61, 65. Okay, so if we get 61 and 65, why preserve the annotations? So Daniel is asking why preserve the annotations? The reason why is so that if you're trying to look at the original hardware, so like I've got the motherboard, actually I've got a couple 2GS motherboards, but they're packed up already. I just want to be able to reference that what is BC30 on the actual circuit board back to the schematic. So I want to make sure that the annotations stay consistent. The challenge comes into Apple's not too bad, but when you start looking at like Commodore, they had like a dozen revisions of practically every one of their PCB designs, even though the computer itself really didn't change very much. So the Commodore is a kind of a little bit of a pain to maintain, but fortunately the circuit is practically the same across all the revisions, so it doesn't take too much to figure out what's going on those. 68, 69. I thought we were gonna finally have a long. So I must have a different page size than what this used, or, oh, I guess the symbols are probably pretty different. So I'm gonna have to figure out how we're gonna lay this out here in a second. What I'll probably do, these are different voltage rails, so I'll just does KiCad have a distribute function now? I think it does, right? I want to be able to highlight all of these and say distribute equally. Another reason I wanted to do this in Python. Although I'm starting to realize we would have taken 4 hours just to do something that takes a couple of minutes without using the proper tools, because I don't know what the right tool sets are. Oh, come on. There's even more. Looks like you're not using the small symbol. I thought I did. Yeah, I am using the small. In fact, I think you told me about the small symbol the last time I was working on a schematic, and almost every single time now that I open up a schematic, the first thing I do is switch all the passives to the small symbol. All right. So 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 16, 17, 18, 19, and 20. So this is the first one where I'm going to say we're going to deviate from the original schematic and kind of group these together. So let's go ahead and just do this. I don't want to add the lines to each of these yet because I don't know how I'm going to format everything. But what I wanted to do was just get a 12. Let's see, this is a minus 12. I just wanted to get a minus 12 volt on there so I know what that group of capacitors is. So let's move this back over here. So the next group starts from 39 and goes to 70, and that's plus 5 volts. So let's grab these. Just going to move them down here so I can work with them. All right, let's do a wire. Same story. Not really trying to format these just yet. Just want to group these together visually so that we can start getting an organization going. Oh, wrong one. 5 plus 5. All right. What are you building with Apple IIgs? Is it restoration or hobby? It's actually hobby. I've got 2 working Apple IIgs's. One of them has a transwarp upgrade, which is great because it makes it really fast. But I don't actually like using it because it's too fast, if that makes sense. I like the original speed, so I usually use my original speed Apple IIgs. And then I've got 1, maybe 2 motherboards that have damage to them. And so I'm going to be scavenging parts off of the damaged motherboards to create a portable Apple II. And so it's just a fun portable project. I've got the screen picked out. I know what I'm going to do for the keyboard. And then basically now at this point, I need the motherboard. And so that's what I'm working towards. So why so many caps? Yeah. So on Twitch, somebody's asking why are there so many caps? It's just kind of the way that these, I guess even modern schematics get done this way. All the decoupling, because they're usually non-critical values, get all kind of slammed into one page. So if you go to other pages on the schematic, like if we look at the chips, there's no decoupling capacitor. Now, one thing to notice though, I think if I got this right, so this is UG12. I think there is references. I think these are supposed to be references to which chip that they're actually connected to. You might not be able to see that. So like this is saying BC34 UH15. I'm pretty sure that's supposed to be a designator to let the PCB artist know that this capacitor and that chip are connected. I'm not positive, but I'm pretty sure that's what they're doing there. So, but yeah, it's just so that when you look at like this schematic where you've got an active IC, you don't have to have the decoupling caps on there. It's just to make it cleaner. All right. So next, let's group together the -5. So this is B8 to B13. B8, what? Oh, there it is. Move this over, do a wire. So wire is just the hotkey is W. And then we're going to place, this is -5 volts, or -5 volt, as a troll corrected me on. I was not aware that it was upsetting people, apparently, that I used the word volts as a plural. After almost 30 years, I didn't realize that that was something that would trigger people, so I will try not to say it in the future. All right, this is another 5 volt section. See, I said it's singular that time. Use the mouse wheel for scrolling. Yep. Oh, yeah. The reason I'm kind of jittery when scrolling around is I keep getting the hotkeys for Illustrator and Premiere mixed up with KiCad, and so I'm just having trouble swapping between the two. So I think the transwarp makes GSOS just about normal speed. Certainly running 8-bit games, it's too fast. Yeah, I mean, for anything that was intended for the original Apple, it's too fast. I agree that the transwarp makes the 2GS a viable operating computer. Like, to me, it helps demonstrate that the 2GS really should have been the Macintosh. Now, history might disagree, but I think there was plenty of opportunity for that 2GS to sort of fill the gap between the Apple II and the Mac, because the Mac was garbage until basically the SE30. I mean, the original 128K, it couldn't even copy a floppy disk without multiple disk swaps because there wasn't enough RAM. And so you know, it just, the original Mac was just so hampered by technology and cost, whereas the 2GS, which was not cheap, but it was a much better use of the available technology, and Apple intentionally slowed the clock of it so that it would be slower than the Mac. That just drives me crazy. I mean, but anyway, yeah, just the reason I make the transwarp comment is because I remember using the 2GS in elementary school, and I thought at the time it was blazing fast compared to like the Apple II stuff. And the idea of using a mouse, it was the first computer I used a mouse on, that was mind-blowing to me at that time. I used to, in elementary school, we had, how did this work out? So there was like 2 or 3 recess periods per day, and you could opt to have one of the recess periods in the library, and maybe it was like library and maybe in the gym or something, I don't remember. But what I would do is I would go outside for the short recess period, and then the recess period that was after lunch, when everybody else was out playing kickball, I would go to the library so that I could use the Apple IIgs. And the thing that I did the most, I still can't believe I did this so many times, is I played the Getting Started, or the tour of the Apple IIgs, and it was basically like, it was teaching you how to use a mouse. And so like there was a little character, and you would click on like basically like a point and click, and then he would try to get to different places. But it took like, I want to say 7 minutes for it to load off the floppy disk. And so that's why I had to use the long recess period, because the short recess period, I would only get like 10 minutes to play. Anyway, I have a copy of the disc. It still works, or at least the copy I have still works. Daniel says, adding plurality is funny, like maths. Yeah, I joked. I'm joking that it triggered somebody. The reality is I mean, obviously it triggered the troll, because I know it was somebody trolling by the way that they worded the feedback to me. And I don't mind the actual feedback of, hey, you realize volts should be singular, because I frankly, I didn't. To me, I think it's natural to say 5 volts and 1 volt, but I get it. Okay. It's a scientific unit or something, or I forgot what the exact phrase or the definition of it is, but yeah, okay, so it's not supposed to be plural. It's sort of, to me, it's sort of like gigahertz or gigawatt. A lot of people say giga. I even at one point made fun of Doc Brown for saying giga, but if you go and look at really how it's supposed to be pronounced, it should be giga, not giga. However, you know, it's a common thing. We just sort of accept it. And so I think your comment that it's sort of like the word maths, I think that's a really good example. It's like every time I hear it, being an American English speaker, we don't pluralize, we don't make math plural. And so when I hear somebody make it plural, it always catches me off guard. But I also think it's kind of cool that, you know, it's like, here's a word that we're using differently, but we both know exactly what you mean, even though we have a slight difference in the usage. Anyway, let's get this done. And this was 5 volts, right? I hope it was. Yep, 5 volts. Okay, copy, place that over there. Hotkey for wire is W. Yes, it is. Aaron says, volts is revolting. Yeah, apparently. Hey, it's Sean from Unexpected Maker, which, if you haven't checked out his channel, you should. He does some really cool live stream stuff. Sort of makes me drawing a schematic look silly compared to the stuff that he does, but definitely go check out his channel, which is Unexpected Maker, and I think you'll find them around the internets using the same phrase. So definitely check it out. So somebody on Twitch is saying that the 2GS was light years ahead of the Mac in terms of audio. Oh yeah, actually, I don't the original Mac didn't even have an audio chip in it, right? It was just a beeper. Whereas the, I take that back. I think the original Mac had a PWM generator, and it might have been able to play audio samples. But the 2GS had a really cool Ensoniq chip that almost no programs took advantage of, because like nobody did anything for the 2GS. It was all Apple II compatibility. But the really cool bit of trivia is that the designer of the chip that went into the 2GS later went on and designed something called a PlayStation. I believe it's some sort of modern game console. But yeah, it was the guy that did the chip for the 2GS actually ended up at Sony doing work for them. So I thought that was kind of a cool history trivia. And now that I've said it out loud, I really hope I got that right, because I might have confused it with the... Yeah, actually, I'm pretty sure I got that wrong. I'm thinking of the sound chip in the Super Nintendo. All right, so what do we got going on here? Yep. All right, and then this one is 5 volts. Move that up, wire connect. Negative 5 volts, we'll just copy this one, put that one there. Let's move these down a little bit. Oh, that's interesting. Are these all chassis ground? Oh, interesting. So these are chassis ground. They're not digital ground. All right. Never saw, oh man, Sean, you didn't see a 2GS in real life? Oh, I feel so bad for you. Yeah, it was, it's a great computer. I've got one sitting next to me. I rearranged my desk so you can't see it anymore. But if you go look at the other streams on Twitch that I did with the 2GS schematic, I actually, I had it running at one point where it would just do the game of life while I was on camera. But now my 3D printer sits where it used to sit, so oops. So that's gonna be regular ground, that's gonna go negative. Let's go ahead and add those because I'm gonna forget. So let's go plus 12 volt. Put that one there. Negative 12 volt. Hit R to rotate that around, and we'll put that down there. Beautiful. Probably should save that. Commodore 64 had an advanced sound chip for the time. Yeah, the SID chip on the Commodore 64 is legendary. I have at least 6 computers, not including the logic boards, that should have a functional SID chip on it. And of those 6, I think only 2 have a functional SID chip. It is almost always the first thing that fails in a Commodore 64 or 128. I think the 128 has a SID in it as well. It has there's the 65, was it 6582, and then there's like the 8550 or something, which some people say doesn't sound as good. So in most of my Commodores, I have a replacement that is based on a ATmega microprocessor. But I was actually reading about the SID chip from, so who did that? Was that Bill Minch? I think, was he the one that designed it? I can't remember off the top of my head. But in like the Commodore book that I read, like I think it's the Commodore Story or Commodore Wars or Computer Wars. 2, 3, 4, 5, 6, 7, 8. he was talking about how there were features he wanted to implement that they couldn't because either cost or they didn't work on the original mask set, and so they got dropped. But the crux of it is, as advanced and amazing as the SID chip was at the time, he had other stuff planned to make it even more advanced, which just kind of, it's like, wow, you mean you could have done even more with it? It's like, that's just crazy to think about. I had a 2 clone back in the day, then went C64 and Amiga. So I know I've seen an Amiga in like real life person, like in person. I remember going to like a Sam's Club or something as a kid, and they would have 8-bit computers set up, and I think there was a couple 16 bits. And so I know I've seen, like, physically touched an Amiga before, but I've never really used one. And so that's actually something that's on my wish list to acquire. Is I think everybody's recommended an Amiga 1000. But yeah, that's definitely something that I need to add to my collection, because I don't have much experience with Amiga, and it's something that I wish I did, because those are really amazing machines for their time. Okay, so I'm just going to say Matrix on Twitch has corrected me. So Bob Yanis, he's the one that did the SID chip, and he also then went on to do the sound chip in the 2GS. So that was the connection I was trying to think of. So thank you, because I couldn't remember. I knew there was a special connection to the sound chip in the 2GS. Which is, again, really disappointing that more software didn't take advantage of it, because it was, it was sort of like the next evolution in the SID, but at the time of the 2GS, like, nobody cared about the GS part of the name. Everybody wanted it just as a Apple II compatible. Yep. All right, cool. Thank you for the... Oh, sweet. Okay, I gotta show you guys this. Not this one. This one. Let's go... This is like... This was, I think, the day after Christmas. I was drinking coffee in the morning, browsing around on eBay just to see what people were posting. And... I show you. So a couple of years ago, I was buying disk-based software for vintage computers, but the reality is almost all the disks that are interesting, at least to me, are already digitized. And since disks are rotting, I'm not really collecting disk-based games anymore. Like, if I find something that's fully boxed, I might still get it because of the box art. But I just thought this was kind of a cool... I hope some of these work, but for, like, I don't know, plus shipping, like $10 from Lodestar Monthly, I'm hoping some of these discs work, because I actually remember, like, getting a magazine with a disc in it and trying out, like, all the terrible programs that were on it. And so I'm hoping some of these work. I think this is for the 64 and 128, which... sort of like the 2GS, the 128 had a whole bunch of cool capabilities that nobody cared about, because they just wanted to keep stuff compatible with the 64. But anyway, I just won that one, so I just wanted to share. All right. SX64. Yeah, I've been trying to buy an SX64 for like 2 years now. And oh my gosh, are people crazy with their pricing on that? Like, especially like on eBay. I saw one go up where it didn't have the original keyboard cable, which if you're looking to buy an SX64, if it doesn't have the keyboard cable, you can make a replacement, but that's like the number one thing, is try to find that cable. And so it didn't have the cable, and it was like chipped in the corner, and the starting bid price was like $600. That's like, who's going to who's going to buy that? I mean, that's ridiculous. I mean, they're usually going between $300-$400 range, but you know, that's with the keyboard cable and where it doesn't look like it's absolutely terrible. So that, but I haven't really been able to find one that was reasonably priced. eBay is almost impossible for it, because if there is one that is at a reasonable price, somebody's going to bid it up into the $400 range, and I just can't stomach spending $400 on a computer that might only work for a couple years. I'd really like to find one that's like got some damage and repair it, but even those are just going, I mean, that's actually what's, I guess I'm distracted, but that's actually what's bothering me, is the damaged SX64s are still going for like $300+. And to me, it's like, if you can get one that's functional for, say, $400, why would you only save $100 on something that's broken? You know, it doesn't, I mean, if you're going to spend $300 for a broken one, why don't you just spend $400 for one that's already working? You know, I don't know, maybe I'm just weird like that. I don't know if I can do this. Nope. So we need VS, which I just realized I screwed up somewhere else too. The Amiga was the first to use the mod format for music because actual sampled wavetables became big in sound cards. Yeah, that's a good point. There's something about, was it the mod format that's difficult to emulate? I remember seeing something on a video, something related to the Amiga sound and one of the complications with using modern emulation, but I don't remember what it is. I don't think it was like the same problem with the SID where the emulation doesn't sound quite right, but there was like there's something about the mod format that made it difficult to emulate. I can't remember now. It's been a while since I saw whatever I'm thinking of. So I can't modify this name, can I? All right, so we're just gonna do a global label because I'm not sure how to handle this at the moment. I don't know what the difference between -5 volt and -5 volt VS is, because this is some sort of RC filter. I wonder what they're doing. So we'll just do it this way. Let me make a note. All right. Yeah, the Amiga was an interesting architecture, but ultimately it couldn't keep up with the PC market. Yeah, I think you could actually say that for just about anything that wasn't a PC. Commodore gear is getting top dollar lately, goes in cycles. Yeah. Yeah, I'm actually surprised that the Commodore stuff shot up, I'd say even in the last 3 to 6 months, because I feel like a year ago I was able to buy Commodore 64s, usually with a handful of accessories, for like the $40 to $50 range, and now they're all in the $100 to $150 range, which, if the SID chip is working, $100 for a Commodore 64 is not a terrible price, but it's definitely, at least for my budget, it's past the impulse, yeah, I'm gonna buy this. When they were like $40, that's why I ended up with so many, because it's like, okay, well, I didn't really need another Commodore 64, but this one came with a dust cover, so now I get another Commodore 64. So what are we doing? Well, right now we are recreating the schematic from the Apple IIgs in KiCad. And so this is part of a project I call Bit Preserve, where where we are recreating scanned schematics for vintage computers and then publishing them to to GitHub. And so the one that I'm working on is the 2GS, and today I'm drawing the capacitor page. In the past, we did things like, the Mega 2 chip as well as other pages. And I'm basically just going page by page of the schematic and copying it. And if you go to Bit Preserve on GitHub, which I thought I had open, guess not. There's a handful of other computers that have already been done. So like we had somebody do the couple of the Commodores, the DEC terminal, the Altair. I think this was one of the first ones that got submitted from somebody other than myself. And then is the Dragon? I wonder how. I haven't actually checked to see how far along he is with the Dragon, but I want to check that one out because that's to me that's just kind of a cool computer since it's outside of the UK. I don't know how well known it is. So, all right, but yeah, so that's Bit Preserve over on GitHub if you want to check out the project. But one of the things that I have told people, if you're interested in learning how to use KiCad but you don't have your own project, one thing you can do is go to Bit Preserve and see, is there a schematic that you could start to work on? You know, even if you could do, say, like a small section of this capacitor page, it would be helpful to the project and it's helpful to you because then you get a chance to kind of use KiCad. So, all right. The Altair was the first home computer. It was. I think we need to always be careful when we say what was first because different parts of the world, different things happened, and there were different things that got released right around the same time. I think the Altair is commonly accepted as the first home computer kit. There were probably others at the time, but it was sort of like the first thing that you could buy as a product, and it sort of looked like a computer. Almost everything else around that same time period was either a calculator on steroids or a development board with, like, you had to add a power supply and stuff. So the Altair is the one that was shown in Popular Science or Popular Mechanics. I forget which magazine it was, and that's sort of what kicked off that home computer craze. So I'm trying to be political and not say it was the first, but yeah, it was probably the first. Let's get these. Two, 1, and 0. Thank you for the follow. All right. So we need, how are we going to do this? Let's do, wrong window. Let's copy this schematic. Oh, I forgot to label these. Shoot. This is SC13, and this is SC20. I'm going to put this here. 2, 3, and 4. I'll move this one up here. So now we're going to do this. That looks pretty good. And this is, oh, we might have to move these over. Yep. Oh, I just remembered. There's a hotkey to move schematics or to shove wires. Is it W? Is it G? Yeah, that's what I could have done. Oh well. Yeah, so if you hover over a wire and hit G, it allows you to move the whole thing around without having to do what I just did. So like if I had left this too close, and then we made this one 104. And it was like, oh no, it overwrites that. So we hit G, maybe G on this one. G. Yeah, that's a lot cleaner. Look at that. That's what we're talking about. 102, 103, 104. Edit 105. So let's go G. Actually, let's move this one over. Okay, that looks stellar. And then we're going to copy this one over to here and do, that looks less stellar. So we're going to use that G hotkey again, and let's just move this up. We can actually move these a little closer to each other, can't we? Look how clean that is. Yeah, I like that. I like them apples. 101. Oh. I wasn't paying attention. These values are all messed up. This is 100 picofarad. Should have done this before I copied them. And this one is 22. So if you're new to KiCad, what I'm doing is I'm hovering over the value text. I'm just pressing the letter E, which brings up the edit value field, edit value dialog, and then putting in a new value. So that's to me, that's a pretty handy shortcut. So we'll do the same thing. So we need to label our resistors up here. I forgot to do that. So this should be, so we'll edit this one to be SR20 and the value to be 100. And this one we will do SR19 and the value to be 100. All right, let's save that. Is it possible to bring in the PDF as an underlay so you can trace over the whole thing? That's an interesting idea. I hadn't explored that one. However, if we went back to the beginning, it would have actually been a little bit of a pain even on this one because of the way that things end up getting formatted. So I don't know. That's a good question. If we could have had an image, it might at least, this schematic, it's not so bad, but like on, was it page 7 is the slots? Yeah, check this page out. This is the one that I'm actually worried about. I've already created this one in KiCad, but with all the lines and everything running everywhere, I think I figured out where everything was going, but it would have been nice just to kind of trace it. However, at the same time, so this is what they did and this is what I did. So I went with the just label the nets and not do the spaghetti stuff. And I know there's people that have an opinion on these two formats, but here's my thought. The whole point of recreating these schematics in KiCad is so that you can use them in a modern CAD program. And so, for example, if I want to highlight a certain net, I can do that, and then I can see where it is everywhere in the schematic without having to trace the lines around. Lines like this, to me, are only helpful in a static image like this one. And so my intent with this project was not to create static PDFs. So for example, one of the rules is that I do not want people to upload a PDF of the schematics that they create, because that to me goes against what we're trying to do. We're trying to preserve these in a modern format. Now, I recognize the problem with that is then in order to look at the schematic, you have to download and install KiCad, but I mean, you have to draw the line somewhere. And so anyway, I probably got defensive on that one, more defensive than I need it to be, but I just wanted to mention, yeah, the tracing, maybe it would help. If we could figure out a way to do it, I would at least give it a try to see how it works, how well it works. It certainly would help when I'm streaming because I'm not used to having such a small screen. But anyway, realistically speaking, the Altair was just a glorified calculator. Yeah, I think just about all those early computers were. Was the Altair, that was based on the, was it based on the, it was the 8080, which was the follow-on to the 4040, which I think was a microcontroller intended for calculators, if I remember the history. Try adding no ERC on a pin which is not connected. It helps in ERC. I'm lost on that one. I mean, I understand what I understand what those words mean, but not in the context of what I'm doing. So, if you're trying to tell me something, I got lost on it. If you're telling somebody else something, cool. Okay. How long have we been going? For about an hour. All right. Here's what we're gonna do. I need to get more tea. My tea is empty. And I need to kind of get up and walk around for just a minute. So here's what we're gonna do. I'm gonna turn the trivia slideshow back, or it's actually not a slideshow. The trivia is actually generated from HTML, but anyway. I'm gonna turn the trivia back on for about 3 to 4 minutes while I heat up some water, and then we're gonna come back and get back to work on this. So I will be right back. I kill this. By the way, if you've got headphones, you might want to reduce the volume, because I think the volume that I'm going to switch to is a little bit louder than what I'm talking. So just heads up on headphones users. I'll just do this. All right. By the way, if you've got an idea for questions or like trivia questions, like around electronics, computers, technical stuff, feel free to throw them into chat. Or we do have an AddOhms Discord that you can come and join and keep the conversation going. That'd be another way that you could send some questions in. I want to keep adding questions, and the way that I've got it programmed right now is it's not supposed to repeat until all of the existing queue is depleted. So, and then if new questions get added, those will get done before we go back to the old ones. So the idea is I should be able to keep adding to it. So if you followed me for long enough, the LED question is a classic one that I like to mess up people on, because the reason I started asking people about, is it the long leg or the short leg? I bought a package of LEDs that now I can't remember. I guess it's the cathode's the short one, or anyway, it was backwards. And that's when I realized the length of the lead is a convention and not a standard. And so for some reason, at some point, somebody manufactured LEDs that were opposite of the convention. And so the joke of it is okay, quick story time, and then we'll get back to the schematic. So I used to teach an electronics class at a makerspace called Tech Shop. And in the class, I showed how to use the electronics equipment on the workbench. And one of the things we did was use the bench and a handheld, I think, multimeter. I would always ask people 2 questions, and it would take until I was going to say it takes until the third, because the first question was, what's the value of a resistor? And everybody would start looking at the bands, and it's like, guys, we have a multimeter. We're in a multimeter class, so we're going to use the multimeter to find the value. And then the same thing with the LEDs, is everybody would say, oh, it's the short leg is the cathode or whatever. And the thing is, I played a dirty trick on every single class. I went in and I cut the legs at an angle so that it was backwards, to point out that it's not always the lead length, that you really should check it with a multimeter. Okay, enough of my lecture. Let's get back to some KiCad schematics. Let's turn this back on. Can you guys hear this music playing? The way that I've got my audio routed, I can't hear what you hear because then I would hear myself, and haven't gotten quite professional enough yet that I can talk while still hearing myself delayed. And I hope you don't mind the music. Since I'm not presenting, there's a lot of dead air time that I thought would be better with. Actually, it seems like the same song has been playing, isn't it? How do I change it? Let's do retro. I think I've tried to play this station before and it doesn't work. Yeah. All right. Let's do chip. What is this? No. All right. So let's try. Yeah, this is what I want. Let's see how this plays. Yeah, you might not be able to hear this at the moment. Let me do this. Because it's like it's not. Oh. We'll put it to about there. Oh, you know what I could do? I know what I can do. Focus output. Let's do monitor. And now it's not outputting at all. Because that's the wrong one. All right, that's pretty loud. All right, we'll try it there. Okay. All right, I'm looking for inductor. Let's do L small. All right. Throw this here, copy this one down here, and copy this one to here. So we've got capacitor, inductor, capacitor, inductor, capacitor, inductor. These two are going to get tied to 5 volt. These are all going to go to ground. Okay. So let's do 22 microfarad, and then E to edit. Now we're back to a regular C convention. This is another, oh man, I did this again. C44, actually do this, and then I can just do C43. Now what I'm gonna do is M to move, and then rotate. Aw, thanks Wesley, you're awesome. Happy New Year's to you as well. Let's move this over here. Okay, so what I'm doing is I'm hitting M to move, rotate, place, M to move, rotate, M to move, rotate, and M to move. All right. Okay, this time I saw your message, Wesley. New Year's Snickers bar fund. Yes. This time I made sure to eat before we started, and while I am getting close to lunchtime, I I did not want to have a repeat of the 555 stream where my hands started shaking and I was getting irritated with myself. Okay, let's see. I think, let's see, do I want to copy what they did? Let's draw some lines and see how this comes out. Although, you know what, man? I'm gonna start Yeah, I'm gonna start. I'm gonna get a Snicker bar stash. That'll be the official streaming snack. Although, maybe not. I don't like having chocolate when I'm talking. You guys want to hear an embarrassing story? So when I was a kid, well, when I was in college, I did an internship, and it was, I think it was my first internship. I was actually, even though I went to school for, why is it, don't pop back up. So I went to school for EE, but I had an internship where I was basically an IT intern. And actually, the primary thing I did was test all of the desktop computers for Y2K compliance, which to this day, I still don't fully understand what we were actually testing. But anyway, so at lunch, I had a brownie, and I ate in my car because I didn't, what was going on? There was somebody that I worked with that really bothered me. And so I found at lunchtime, if I just went and ate lunch by myself, I got a break from them. And so it gave me a chance to unwind. And so I would go to like a Boston market or something, get a sandwich, and then I had a brownie and a few extra minutes. So I decided to eat the brownie while still in my car. Well, the brownie exploded, and I didn't notice that I was sitting on bits of the brownie wearing khaki pants. And so I walked around for like 2 hours before somebody said, "Hey James, I just want to let you know that you've got a little something on the back of your pants." And I thought, oh man, I must have I must have sat in something, or maybe I brushed up against something that was dirty. And when I went and looked in the mirror, it literally looked like I pooped my pants. Like I just had this run of brown smudges down my pant leg. And it was only like 2 o'clock in the afternoon. And so I was like horrified, because I'm like, well, what do I do now? I didn't poop my pants. It's a brownie. And I had to walk around, so people were going to keep seeing it. I didn't have a change of pants. It was just like such a terrible, I did the best I could to clean it up while I was in the bathroom, which I think just made it worse. But it was so embarrassing because it literally, that's totally what it looked like, and it wasn't. Also, I clearly remember the brownie was terrible, so it wasn't even worth having the brownie. So there you go. Fun story from the Bald Engineer. So who are you when you're hungry, AddOhms? I don't know. I get frustrated very easily. I think like most people, I think people call it hangry because you're angry and hungry. That is definitely how I end up getting. Oh, that's not gonna work out well. I don't like how this whole thing is becoming a mess right here. Make an emergency break glass box for their desk. Actually, you know what I like the idea of is, it won't work when I'm doing the green screen, but like when I'm at my workbench, I should have like an emergency break, a Snickers bar, break in emergency, and then have a servo motor that breaks the glass. I'll get like something like really thin and make it easy to break. And then if somebody does like a super chat of say like $10 or something, they'll break it, and then and then I'll know it's time to have a Snickers bar. Okay. I'm actually, hold on. I'm gonna add that to my ideas list. I don't have it open. Okay. All right. Okay. Oh, let the servo motor open the glass so you can reuse it. Well, fine. Yeah, okay. That's a much better idea. I like the idea of. Oh, I know what we could do. I know what we can do. So it could be a door that opens, and then we'll get like the DF robot MP3 player and have it play the sound of breaking glass. So that way it's a little bit safer. So that would work. I don't like this. I don't like this. Oh, okay. I already. Okay, I know what we're gonna do. We're gonna delete that and move this, and then extend this to here, and then we're gonna do this, and then move this, and do that. Okay, I like that looking better. And then I'll just do labels onto the header for those, which I think I already took out for some reason. I did. So let's add was this 1, 2, 3, 4, 5, 6, 7. M07. If you guys aren't familiar with it, is it, I'm gonna get his last name wrong. I think it's John Oxer, or is it Oxley? So John from Freetronics, he's got a YouTube channel, but it's like Super Fun House or Super House TV. I forgot the name of the channel. But anyway, Freetronics does a lot of really cool, like open source type stuff. You know, I would put it in the same kind of category as SparkFun or Adafruit, but based out of Australia. And he released a KiCad schematic library with a bunch of common symbols that I personally use almost all the time. So like I like his pin header symbols quite a bit actually. So anyway, I just wanted to mention it because I am using his schematics, and so you should go check out Freetronics. I'm trying to remember, how do you I want to flip it on, I want to flip it on the x-axis, so I just hit X. That's the y-axis, idiot. All right, so these are going to be easy. They go to ground. Oh, power is in, I don't think I knew that. I didn't know power got added to the place symbols. Like, I think in previous versions of KiCad, that was not the case. All right, 4 is something, so that's still going to be in my way. Let's move, oh, nope, copy this one to here. And then this one goes to 4. And then 5 goes somewhere and 7 goes somewhere. Oh, I can actually see it now. 5 is 12 volt raw. I bet 7 is negative 5 volt. Oh, sometimes. See how many Snicker bars he can eat in one show. Well, I can tell you that number. It's going to be half of 1. I don't actually like sugar very much, and so anything that has a lot of sugar in it, I can't really consume much of. So like candy bars, yeah, like a Snickers bar, there's no way I could finish a whole one. Although I guess I could maybe eat the whole one over the course of the show. Like if I stream for 3 hours, I could probably eat a whole candy bar in that time or drink a whole can of Coke. But like I almost never can finish a can of Coke. It's just it's too sweet for me. All right, so from YouTube, reminds me of the scene from Look Who's Talking where the guy didn't know English, gave the guy all the candy bars, and he became combative. I don't remember that. Was that in the first or second one? We're gonna go with J22, and I'm gonna head and let's go ahead and label it Molex 7-pin, because I think this must be the connector for. Well, I don't think the power supply has a Molex connector though. I think it's just an edge card. I mean, it could be from Molex. Because the way that the power supplies for the 2GS work is it's a long rectangle that like plugs in. And so I'm wondering if this is plugging into there. The official AddOhms hangry hangry treat. That's a good question because I don't really like snacks. My favorite snack is prosciutto and cheese. Not to be snobby, I just really like the taste of prosciutto and cheese. So, all right. So this is like the same schematic, just in a different location. So what if we move this over here and just try to recreate? I might come back later and totally redo this, because I think I see what they're doing. Like, it's going to go something like this, I think. And then this is going to be, so what they're building, this is my guess. Okay, so my guess is, well, wait a minute. I was gonna say this must, oh, okay, yeah, there it is. Yeah, okay, yeah, so what they're doing is we're getting the rails right off the power supply, and then, you know, typically when we think of a decoupling capacitor, you really want a decoupling network so that you have some filtering that's taking place in addition to the action of decoupling. And so it looks like what they're building here is just a basic decoupling network to help filter out a little bit of the noise as it comes off the power supply. This may also be trying to compensate for the amount of inductance that, like I mentioned, there's kind of like this connector system that goes in that they're using. So they might just be trying to compensate for that. But the fact that they're just using 10 microhenry and 22 microfarad, well, I don't know, 22, it's not a decade value. Anyway, doesn't matter. All right, so let's put this one here, and then put this one here, wire this to here, wire this to here. So one of the things I do on my day job, one of the applications that's really popular is power integrity. And I really wonder, like, how did they do power integrity? So that's basically where you're trying to make your power supplies, like especially your switching power supplies, behave very well across a wide variety of conditions. And if you look at a modern design, the amount of math and simulation that goes into it is mind-boggling. And I just can't imagine in the 80s. I mean, the math is probably still there, but the iteration and doing multiple iterations in design, I just can't imagine that they had the resources to do it. which is actually how you ended up with a lot of decoupling stuff that's like, oh, just add a 1 microfarad in parallel with a 100 nanofarad capacitor. So from Twitch, I knew a guy who worked for a company that made custom microwave filters. Yeah, that's actually, so Chris Gamble had a tweet about a week or so ago about your goals for 2020, and RF is on, the 2 of the 3 that I listed were, if I remember correctly, were RF related. One of the things I was building for a while and need to get back to is I want to make a calibration standard for my VNA, which is basically, the reason I need the calibration standard is so that I can then build microwave filters or not microwave, RF filters, and see how well they work. So you said microwave, I'm thinking RF, close enough, or they're pretty close. I shouldn't dismiss them. C46 and L7 and C45. Cool. Yeah, that looks a lot nicer. Just thinking about, why did they do this over here? They must have been thinking that there must be a lot more current on the 5-volt rail than everything else, because it's only got 1 line coming off the power supply, I think, and then, that's interesting. Oh, we need to add 5-volt and 12-volt. So let's do 5-volt on, 5-volt on this one. Copy this. Let's do 5-volt on this one. And 12 volts up here. 12-volt on that one. All right. Close enough for government work. Oh, we need a power LED. It's on the 12-volt rail, which I put up here instead of down here, of course. So let's just grab all of this and move it up here. Grab all of this, move it down here, and then put this up to here. All right. Let's add LED. Small, and where they got it, right between the inductor and the capacitor, the capacitator. I don't see a resistor anywhere nearby. Let's go R small. Wait, what stop do I have? Oh, shoot. Am I using US or international resistors on this project? International. Oops. So let's just change this to R small. Copy that, and then edit this, and then we'll just do that. Okay. Let's try to be consistent. And then down here, we're going to do R small. And well, that's not what I expected to see at all. Let's do R111. So that, I guess that's clever. So they're doing a 7-volt drop. I wonder if the idea here is this single LED will only illuminate if both the 12-volt and 5-volt rails are active. Not sure. Yeah, power supply design. So from Twitch, personally, I hate power supply design. It's so complicated. I mean, it really is. You get over. I mean, I say anything over 1 amp, and you really have to worry about things. But the reality is, even at small currents, you can have issues, especially if you've got something running like in the couple hundred megahertz range somewhere on the board. I used to think that how hard can it be to do a power supply? You just go to TI's web bench and design some parameters. And I think for a one-off project, that's probably fine. But then when you start looking at all the variables that can cause a power supply to become unstable, it's significantly more complicated than people give. Power supply design is significantly more complicated than people give it credit for. Are microwaves fundamentally different from radio waves? I'll see what the rest of the chat says, but my interpretation is no. It's just a matter of what the wavelength is. Now, because different frequencies have different behaviors associated with them, there are differences in how we handle them, but fundamentally, it's just different frequency of a wave. So what are we building? So right now we're recreating the schematic from the Apple II GS in KiCad. This is part of a project I call Bit Preserve, which is actually trying to catalog these vintage schematics in something that's modern, editable, and usable. The reason I started this project is because I'm building a portable Apple II based on a special chip that's only found in the 2GS. Correction. There's also a version of the chip on the compatibility card for the Mac LC. In the 2GS, it's called Mega, and on the compatibility card, I think it's called Gemini. It's got a name like that. It's not. I can't remember now for sure. Anyway, so that's what we're building. We're building a schematic here of the 2GS, and then later on, the whole reason I'm doing it is because I want to recreate or because I want to build a portable Apple II. All right. Ooh, fan connector. We can definitely add that. Let's do a M02. And I'm going to press Y to flip it. Even though this schematic, the original schematic is left, I want to keep all my header pins in the same orientation. I am also going to use X and flip this so that pin 1 goes to ground and pin 2 goes to plus 12 volts, which we should have over here. And oh, that was terrible placement. Terrible placement. And let's go ground. Do that. Oh, look at that. It actually looks like crap, but I'll clean it up later. All right. This is going to be fan. I'm just going to say fan con. And wait, I did that wrong. This should be JP24, and we'll make this fan connector. And then I'm going to move this over here just so it's a little bit easier to read. There we go. Let's save that. That section has -5 volts. You have +5 volts. Okay, so Michael's saying that section has -5, you have +5. Okay. Oh, thank you. Yep, you're right. This is -5 volts raw, and this was supposed to be, -5. So let's add -5. Thank you very much, Michael. I think it's Michael, right? That would have been not so good. So negative 5 raw, negative 5 to here, because this is the 5 volt up here. And then if we look at this connector, so 1 and 2 is ground, 3 is no connect, 4 goes to plus 5, 5 goes to plus 12. Yeah, that's how I got confused. Okay. 6 is negative 12, and 7 is negative 5. Okay. Yeah, I got confused because I wonder why they did this, where they have plus 5 minus 12 and then plus 12 minus 5. Why not put them together? I don't know. Resistor should be 220. You put 229. Thank you so much. Escape, edit, 220. Much better. R111. Under C44. Ooh, what is that from? What's that connected to? Oh, that's really confusing. So that's two things we're gonna change. All right, 22. And then just to keep these a little more consistent, let's move those to here. The inductors, they're a little bit better. Those look about right. Do you have an actual VNA with cal standards? So I have a one port VNA. It's the FPC 1500. So it's from Roder and Schwartz. And I have a calibration, an auto cal for it. It normally sells for like $1,000, and somebody sold it as non-functioning on eBay for like $200. So I picked it up and it works fine. I have a feeling they didn't know how to use it, and so they just assumed it wasn't working. Because when you plug it in, if you plug it in without something enumerating it, it blinks a red light. And I have a feeling they plugged it into their computer, saw the red light, and said, "Oh, must be broken." So anyway, so I've got an auto cal, and my goal was to. I'm trying to think how far I want to go with this. So my original goal was to create a cheaper cal standard for the FPC, because the one that RNS wants you to buy, even the passive one, is like $600 or $700. What I don't understand though is the way that the FPC does its calibration. It has to have a specific electrical length, and so in the correction factors, you can't specify a different length. So I got stuck on that. I did pick up a nano VNA, and I have been experimenting with that. And so my goal was to use the AutoCal to calibrate my FPC so that I can properly characterize the standards that came with my nano VNA. And I just haven't gotten to it. In fact, it was one idea I was thinking about doing on the stream today, but I don't have my my workbench set up for that. You have two L7s. Yes, that is totally incorrect. So negative 5 volts is L8. Thank you. Yeah, very soon I'm going to do some streaming with the Nano VNA. I really had wanted to do it today. I just ran out of time to get things set up for it. I could probably stream it from my desk. It's just we'll get back to doing that one soon. All right. So wait, I want to take one more quick look. So 42, 43, 44, and then over here is 45 on -5 and 46 on +12. That's L7, L8. L1 is negative L5 and 6 to +5. Okay. I like the squiggle resistors. Yeah, I don't know. So check this out. And this is one of these things that I probably learned in school and just did not remember. And somebody pointed this out, and it actually does bug me, and I feel like I need to fix this at some point. So let me see. So over here, I've got my AddOhms logo, which I thought was clever. It's, you know, plus sign, resistor, AddOhms. However, it was pointed out to me, and I still cracks me up that I didn't realize this. There are 4 or 5 points on the symbol, and it turns out that one of the symbol conventions is 3 points is a resistor, and anything more than 3 indicates a heater. So inadvertently, my logo is add heater, not AddOhms. Oops. This is what I'm trying to get to. So, frankly, after realizing that mistake, I started using the international symbol on the schematics that I draw, just because I'm like, I don't want to make that mistake again. So, all right, let's get over here. 20, 100, 19, 100, 20, 22, 13, 22, V. Okay. These are going to analog ground. Do we have a symbol for analog ground? Just bring in the heat. If you put enough current through resistor, it will become a heater. This is absolutely correct. If you put enough current through anything, it will also become light emitting. For example, diodes, or not diodes, capacitors can become LECs, light emitting capacitors. The problem is they only work once, and it's kind of a flash, not so much a... Okay. Let's move this up. Do that. And can I just copy the wire? Yep. Oh, okay. Okay, this is what I wanted to fix before I start doing that. No. I just want to select you. And then, nope. Darn it, I was hoping that there was going to be a distribute command. So I guess what we can do is this. We'll just say that's the spacing I want. And then if I do this, and anything that does not fit that spacing is wrong. Which, why did that work this time and not last time? That's weird. And then, okay. Now that I did that though, those are too long. I don't like it. That was dumb. Because what I really want to do is get halfway into here and do that. So we're going to delete this. Oh, come on. Play along. Copy, paste. Paste that to here. Copy, paste. See, wait a minute. Why are these? Why is the distance from here to here the same, but from here to here is not? That's the same. That's the same. That's not. What? Actually, I see it now. That's the same. Okay, whatever. This might actually be faster. Well, it's about the same speed. The difference is I was trying to get my spacings equal. Okay, let's do ground. I think all this stuff just connects to ground, right? Yeah. All right. So that takes care of whoa, 1 through 7. Okay. Save that. I wonder how old the magic smoke joke is. Yeah, so from Twitch, PCB New has the ability to do distribute distribute equally, both horizontally and vertically, which I use all the time in like when I'm doing graphic stuff. I'm just surprised that schematic doesn't have it. BC5 is way off. Yeah, I think it's fixed now. Yeah. It was the one that was messing me up earlier. Okay. All right. So let's just sort of do the same thing here. In fact, what I could probably do, let's get all this cleaned up. Wait a minute, can't I just like, how do I get, I'm thinking of the PCB editor. I was hoping I could just get the Y value, and then I can just, yeah, all right, fine. So I know what I need to do. We're going to delete this, and we're going to do a wire through here, and a wire through here. Okay, so these need to come up 1. All right, so now those are in the right place. And then we just need to do wire up. Makes me think of Purdue and boiler up. Of course, if I had done this when I was copying and pasting the schematics, that would have been a lot smarter. Whatever. All right. So now if we connect these. We can move this guy back down, and he should be right about there. And then we can connect these. So I did have that one's a little bit higher, but I'm really not gonna go that far. Wait, you know what I didn't do? Okay, I might give up on this because now I feel like this is being a little too pedantic. Cool, new follow, thank you. Well, I thought I was being pedantic, but I was also really close, so why not fix it? All right, let's save that. What are you trying to do? At the moment, I'm just trying to clean up what I'm just trying to clean things up. What is the project? Well, we are recreating the Apple IIgs schematic, which I have a scanned PDF of in KiCad. The idea is to recreate vintage schematics so that they are in a modern, usable, and I'll call it sustainable format. But what I mean by sustainable is just that I picked KiCad because it's open source, and so I think 20 years from now, somebody's going to have a binary for KiCad and some way to run the binary. So it'll be easy to open these up and actually work with them. And so this is part of a project I call Bit Preserve, which for some reason I keep closing the window. Google's going to think I really like this for some reason. And so other people have contributed a number of systems other than just the Apple IIgs. So we've got some Commodore stuff, the Altair 8800, as well as a few others. And so the idea is to catalog vintage computer schematics in KiCad. And so I'm working on the Apple IIgs. The reason I started the project is because I'm working on a portable Apple II based on the Apple II ASIC found in the IIgs. There's actually a chip that implements all of the support logic found in the original Apple II as a single ASIC in the IIgs. So it makes it actually very possible to make a portable or small Apple II. So like most cases, start one project and it led to something much bigger. And so today we did the capacitor page, which is basically all the bypass capacitors or decoupling capacitors. And at the moment, I'm just kind of going through and doing some cleanup as I look to make sure I grabbed everything that I captured everything I wanted to capture. And so I was making a comment. I'm being a little bit pedantic in the placement only because I can. So what we're going to do is this, 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 and this. And then I'm going to delete this one because we're going to move this over by 1 pixel. And T's in the way. Move this over, and move that over. And then I'm actually going to delete all of these. Oh, nope, undo that. What I want to do is copy, paste this. Go ahead and we'll just do this for the moment. I don't need that one. This should be approximately there. Connect all those. So all right, and then we can go and add our ground and wire that up. The project seems to be 157 bypass capacitors, but it's in fact an Apple IIgs. And so in previous streams, so if you go to Twitch, twitch.tv/baldengineer, there's other streams where we did what I'll say were more interesting pages, like this is the Mega 2 chip, this is the one that I'm after. So we've definitely done a lot of other pages. The capacitor page is one that I've just been putting off for the longest time because it's pretty tedious. Originally, I was thinking about trying to write some Python scripts to automate everything I'm doing on this one, but I think the reality is the amount of work involved in doing that would be about the same as what I'm doing right now. And so one of the reasons I like this project, the bit preserve project or recreating the schematic, is it really gives you a chance to experiment with KiCad. You know, I think there's a lot of people that are interested in the program, but they don't necessarily have a project in mind. And so it makes it a little bit harder to learn how to use it. And so this is a case where you could actually use this as a way to learn KiCad, which I do think if you're interested in electronics, you should learn how to use. All right, so we're going to do the same thing. There's probably a way to turn on a grid for this, isn't there? Let's get these in place and then we'll finish this up. Boy, this just really compounded quick, didn't it? Let's do that. That works a lot better. All right, so that looks pretty good. Make sure these are all roughly in the same spot. And then we'll just undo everything we just did. Or I just mean delete that. And then I'm going to do this. Oh, nope. I'm going to try this. Duplicate that. That should be fast enough. Let's get that going. Beautiful. Does KiCad evaluate the schematic and report errors or problems? Question from Twitch. It can. It's called ERC or electrical rule check. Because of the way I'm building the schematic, ERC is not going to really help me too much. Uh-oh. What? How is that out of place? Is this last one out of place? But yeah, so KiCad does have a ERC or electrical rule check that's available. I'm not using it on this project. We could, I just didn't. Maybe when the schematic's all done, we can go back and look at how to add it in. But my real focus is just to get this captured and move forward. Now, let me back up. Just in case the question was like, will KiCad look at an electronic schematic and say, oh, you forgot to add a resistor, or you have, or you made a mistake like that? No, it's probably not going to help you with that. What it could help identify are potential shorts or things that shouldn't have been connected, but it's not like it can look at a design and say the design itself has a problem. There are ways to do something like that, but like what I'm thinking of is, you know, basically simulations and things like that. So why are there so many capacitors in parallel? Is it just one bigger cap? Good question from YouTube. So why are all these capacitors in parallel? This is a pretty common thing for larger schematics. So what they've done is I'm looking at the original schematic just so you can see this is how this was done originally for the 2GS. But I see this all the time, like FPGAs or anything that has a lot of pins, you'll see almost the same convention. So instead of putting bypass capacitors with each IC, all of the decoupling capacitors are on a single page. And so they're all listed here. And then like if we go to the previous page, there's this IC, there's this IC. And so if we look at the VCC pin of this IC, there's no decoupling capacitor. And so it's just a way that on the other pages, it makes it much cleaner to look at this chip, because there's really no value in saying there's a decoupling cap here, because everybody knows there should be. So they're all just moved to another page. And so this isn't something that's only in vintage schematics. Like I said, if you see like a high pin count part, like a FPGA, they'll do the same thing. All the decoupling caps will be on a separate page. So that's why there's so many, is that we're just looking at just a page of decoupling capacitors. Grid button, fourth down, turns on crosshairs. This one? Wait, what? Okay. Yeah, if I had done this correctly, I should have probably done it. Okay, I don't want to do. Yeah, okay. That is definitely the right way to do this, and it's not how I want to. Although I feel like this is the second time you've given me advice, and I first said, no, I'm not going to do it that way. And then I ended up doing it that way because it was really good advice. Because what I should have done is set my grid to be whatever it is that I'm spacing these right now, and then I could just use the grid lines to do this. That's what I should have done. What? I hit M to move. M to move. Oh, oops, two symbols. So, no, I don't know that E or C would have caught that. I was going to say that's an example of something that E or C could have caught, but I could be wrong. Beautiful. Save that. Turn on crosshairs. Anything more like 10, I would do this as well. Now go to preferences. So how do we want to do this? Wait, what is horizontal pitch of repeated items? How to make a capacitor power bank without supercapacitor. Actually, if you look at solid state disk drives, they don't use supercapacitors. They use high energy tantalum capacitors or tantalum polymers, which are like 1500 to 2000 microfarads per cap. But in that case, they're only charging to 5 or 6 volts. But I mean, the challenge with using a supercapacitor for a power bank is that they have a really low working voltage, like 1 to 3 volts. And so you have to series them. And when you put capacitors in series, the capacitance drops. And so a lot of power banks just rely on traditional aluminum electrolytics. They do better with temperature. They don't necessarily, they do better with temperature. They're really cheap. It's just that they're relatively large. So bank them up and there you go. So what I was looking for is preferences. I don't know what I'm looking for now. Okay. Here's what I'm going to do. I think this is a good stopping point. Well, No, it's not. Let me just finish this. I know the right way to do it is to use the grid, and I should have done it that way, but I just want to get done. So I'm just going to finish this way. Although, we'll at least turn the grid on, because then at least I can count. What I don't, so Geek, what I'm not getting is, why do I want the crosshairs turned on? I mean, I think it actually makes it harder, but I might be missing something. I think, oh, I need to go back to my schematic, because was it that this, oh, wrong page. This group were the, okay, so I didn't even finish these, did I? Okay. So 5 volt, this should have been BC85, and it's 100 nanofarad, and it is analog ground. And then let's move this just to be in line here. All right, and then this is BC87. If you're new to KiCad, I'm hovering over the label, pressing E to bring up the edit dialog, and then editing my part. If this was a fresh schematic, I would actually leave these as question marks and then just let KiCad annotate them. But I want to keep the same annotations that are in the original schematic, So that's why I'm manually doing the annotation. So this is negative 12 VS. 0.1.1. Let's bring, okay. So I guess I wish the crosshair would stay on. I will clean it up in a minute. I want to finish these. Why didn't that work? 0.01. Bring these here, this to here. Let's kill, nope. Kill these. Bring this down here. Ah, scroll does not work the same in Acrobat. So I have 8655. What I didn't do though, oh, come on. All right, I'm not doing that for now. So 55, 52, and these are both 0.0. Kill this. All right, well, if I'm gonna take the time to do this correctly, so skip this one, comes to this one. This should come over to here. Why are these running into each other? Because this should actually be on this column. And then I can do this, and we can do that. And then let's move this up 1, and move that down 1. However, that seems to be incorrect strategy number 1. Okay, I see what I did. So then let's bring this one over here. This capacitor, that capacitor. Do that. I do want to keep these connected. I just realized I want this to be over one capacitor column. All right, and that's 51, it should be 0.0. So these must be the high frequency decouplers or filters. I bet these go in parallel with one of the ones up here somewhere. So that's plus, minus, plus, and that's all over the place, but tough. All right. Okay. 0.01, 0.01, 0.01, 0.01, 0.01, 86, 55, 52, 54, 51, plus 5, minus 5, plus 5, plus 12, minus 12. Oh. Why can't... Oh, never mind. Plus 12, minus 12, plus 5, 85, 10F. Okay. I remember the old DRAMs had to be refreshed at high speed because of tiny capacitors used in the chip. Yeah, actually, modern DRAM's the same way. Almost all RAM that's used in, well, I mean, any computer system, relatively fast computer system is DRAM, and it still has to be refreshed. Now, the methods of getting refreshed are different. Like there could be an onboard controller that refreshes itself or something like that. But yeah, DRAM's still super popular today. Thinking about the 6502 versus the Z80 or the Z80, one of the advantages of the Z80 is that it had a built-in DRAM refresh. So it made it much easier for designers to implement since... How am I going to do this? I'll just keep doing it. I'm going to keep doing it my wrong way. Anyway, so the Z80, it could do DRAM refresh without an external circuit. The 6502 required a separate controller to keep the DRAM refreshed. And so, like, if you go back to the VIC-20, now I'm feeling like I'm going to get this wrong. So the VIC-20, I'm pretty sure used SRAM. And I'm thinking the Commodore 64 used DRAM. But for some reason, I'm thinking they went with SRAM on the 64. No, they didn't, because no, they used DRAM on the C64 because the VIC-2 chip, which does the video generation, has the DRAM controller built into it. And part of the reason that they were able to do that is because they took all the sound out of the original VIC. So VIC is Video Interface Controller. And because of that, they were able to they had enough room on the silicon for the DRAM controller. I think that's how it worked. Anyway. Oh, come on. Move this over. Move that. And let's get that. Done. Awesome. And I'm hitting W for wire, and then I'm just going to drag my wire all the way across. And I'm going to do the same thing up here. Hit W. It's going to drag the wire all the way across, and then connect that. Double check that this whole block goes to the correct ground. This is B37. See, this is like where I would love to be able to just hit Control F, B39, and see where it's at, which if you let it OCR, maybe it'll work, but I've actually had a lot of, okay, yeah, this goes ground. I've had a lot of issues with these older schematics because the fonts aren't all that good and the scan's not all that good. So all the more reason we're doing this project. All right. Okay. All right. Martin says he can't, so Martin over on YouTube says he can't stand EE schema and PCB new in KiCad, and I completely agree with you. Just call it schematic editor and PCB editor. I love that, like with version 5, PCB new is still called PCB new, even though it's been PCB new for several versions now. It's like, okay guys, it's not really new anymore. Yeah, all right. We're gonna save that, close this. I'm gonna start wrapping up here. I wanna thank everybody for their help on the schematic. I still need to go through and just double check this page and make sure that it's clean and looks good. There's a few more cleanup things I wanna do, but for the moment, I'm happy with getting the vast majority of the work done. So let's go ahead and do this, and then let's do 2GS, or add it, decoupling capacitor page. Still need to verify. Need to verify. All right, so let's commit that, push. And I'm not going to merge that back to the main branch until after I verify the page, but at least it's up there in case somebody wants it for some crazy reason. Oh, look at this. So much bigger now. All right, let's close that. Okay. Well, that was weird. I know you didn't see that, but that was definitely weird, whatever just happened. A couple of things I just want to point you guys towards. If you don't know what's going on with me, I'm going to show you a couple things and then we'll wrap up. I load a couple pages, Workbench Wednesdays. So, so if you didn't know, I do have a blog, baldengineer.com. It's basically cataloging everything I do, but tons of tutorials and stuff on there. I also have a show on Element 14 Presents called Workbench Wednesdays, where we look at test equipment and other things you find on your electronics workbench. The most recent video was on the Analog Discovery 2. I actually did a review of that. And then I'm currently working on videos on how to do a 4-wire DMM measurement, and I'm going to look at some ways to measure temperature using tools on your workbench. But a lot of interesting things there. There's some reviews, and then there's some instrument basics. So power supply, DMM, spectrum analyzer. If you want to know how to use the gear on your, on an electronics workbench, that's the idea. I think most of you know about my YouTube channel, AddOhms. It's been a while since I published an edited video. Most of my video time has been taken up by Element 14. And so I do have some videos in the works, like I've got scripts and some graphics ready, but I just haven't had a lot of time to work on those. And it's probably going to be a few more months before I get there, because in the April timeframe, I'm planning to hire an editor. And once I do that, I'll be able to get more video content out there. But one of the reasons I wanted to point you towards AddOhms.com is, if you're not already, we do have a Discord server for AddOhms where we discuss lots of things related to electronics and lots of things that have nothing to do with electronics. So after the stream is over, if you want to keep the conversation going, there's a link there. I think there's a hot link where you can just do AddOhms.com/Discord and that'll dump you into it. Yep, looks like it does. So that's an option as well. For now, I'm going to wrap up. I will turn the trivia back on for another 2 or 3 minutes, and I'll be hanging out in the chat, and like I said, I'll be in the Discord. I want to thank everybody who provided some help regarding using KiCad today. Made a lot of progress on the 2GS project, so I'm pretty excited about that. And I'm not promising it yet, but I'm thinking I'll do another stream on Sunday, and maybe we'll finally get to the Nano VNA. It really depends on what videos I get done before Sunday, because I don't like moving my cameras around that much. Anyway, my name is James. I'm the Bald Engineer. Thanks for stopping by. If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.